Hello everyone, welcome back to EduMoon tutorial series. I am Karthik, the instructor for Object-Oriented Programming. In the previous lecture, we started from procedural paradigms, object-oriented paradigms, and completed till advantages and disadvantages of object-oriented programming. In this lecture, we will be covering introduction to UML and description of various UML diagrams. UML stands for Unified Modeling Language. UML is a general purpose modeling language. This UML is used to model a system to visualize it. The main aim of UML is to define a standard way by which we can visualize a design system, we can also plan or create complex systems, and we can communicate to non-programmers, that is businessmen or many others who don't know any programming languages. So UML is linked with object-oriented design and analysis. Now, UML can be divided into two types. One is structural diagrams and the other is behavioral diagrams. The structural diagram portrays the structure of system and subcomponents. The behavior diagram helps us in looking into the dynamic aspect or behavior of the system. Now let's learn about structural diagrams. The fundamental UML diagram of structural diagrams is the class diagram. A class diagram is static in nature. It describes the attributes and operations of a class and also the constraints imposed in the class. For example, let's consider a class of customer. The constraints imposed are the name of the customer should be in a string format and also the age should be an integer. The operations of the customer class is to send order, that is to place an order, and also to receive the order which he placed. The purpose of class diagrams are to make analysis and design of the static view of the application or the system which we are building. And also it is used to describe the responsibilities of the system. And using the class diagrams, we can provide a base for component and deployment diagrams. And class diagrams are also used for forward and reverse engineering. Forward engineering means to build an object based on the blueprint or the design schema. And reverse engineering means to predict the schema or blueprint based on the actual object. Now let's look into the UML diagram of the class diagram. So here we have a customer who can place an order. Here 1 stands for one customer and N stands for N orders. So that means that one customer can place N orders. And the orders can be divided into two types. One is a special order and the other is a normal order. And depending on the categories of the UML class diagrams, there will be special features for each individual subclasses. The second structural UML diagram is the object diagram. We all know that an object is an instance of class, and they are the actual implementations of the class diagram. The object diagram tells us how the functions and the data members are related to each other, that is, the data and the functions. The purpose of object diagram is it is used to make the prototype of a system, and it is also used in reverse engineering and to model complex data structures. An example of modeling complex data structures can be given as how to build a graph using an array of linked lists and many as such. Now, the other purpose is that you can understand the system from a practical perspective, that is, how it exists in the actual world. Now let's look at the UML diagram. Here we know that we have a customer whose name is a string and an age is an integer, that is a number. Now the customer can place any number of orders. Here he is placing 2 orders, and in the first order it's a special order and the second order is a normal order. The third type of structural UML diagram is the component diagram. The component diagrams are used to model the physical aspects of the system, that is, the executable files, libraries, documents, etc. It does not describe the functionality but the components which provide the functionality. The purpose of component diagrams are to model the component of a system and to model the schema for databases and to model the executables of an application. It is also used to model the system's source code. Now look at this example. Here we have a sample C program, that is a file which has the source code of C programming language with an extension of .c. This file on going into a preprocessor will give a sample.i file, which is also known as the expanded source code. And this expanded source code, on getting compiled by the compiler, will form an assembly language code. This assembly language code, on being sent into an assembler, will lead into an object file, that is sample.obj. Now this sample.obj will contain all the necessary files, that is the machine instruction code required into an executable file. This object file, on being linked with the linker, will lead into an executable C file. The fourth and the last type of structural diagrams are deployment diagrams. These deployment diagrams are used to visualize the physical components of the system where software components are deployed. These deployment diagrams include the terminals of an actual physical component. The purpose of deployment diagrams are to model the hardware topology of the system. It is also used to model the embedded systems. And this is also used to model the client-server system, and deployment diagrams are also used to model the distributed applications at an operating system level. Now let's look at the UML diagram. Here a user is using a modem to send requests to the internet, and the request on reaching the internet will be processed and will be further searched in its web container. A web container is basically a collection of web servers and application servers, which on further processing will retrieve data from the server 1, server 2. That is, we can say them as many servers in which the data is present, and also from the database server. Now let's look at the behavior diagrams. The behavior diagrams generally tells us about the dynamic nature of the system. The first behavior diagram we'll be learning is the use case diagrams. This is used to capture the dynamic aspect of the system, and a single use case captures a particular functionality of the system. The purpose of use case diagrams are, these are used to know the requirement of the particular system, that is the requirement analysis and a high level of design. The other purpose is, this is used to model the context of a system, that is, what's the state of a system at a particular context. And the use case diagrams are also used in forward and reverse engineering. Now let's look at the UML diagram. Here a user can place an order which is of type either special order or normal order. And in this sense we can see that the user is placing an order which can either be special order or normal order. And these are the two use cases which can be used by the user. So these are the two scenarios or situations which can come up when the user is using the particular system or an application. The interaction diagrams are used to model how the different elements of this particular system interact with each other. The interaction diagrams can be displayed or portrayed using two diagrams. One of them is the sequence diagrams and the other is the collaboration diagram. The sequence diagram lays emphasis on the time, that is the sequence in which the events occur, and the collaboration diagrams lays emphasis on the structure. The purpose of interaction diagrams are to model the flow by time sequence, that is by the sequence diagram, and also to model the flow by structural organization, that is by the collaboration diagram. And these are also used for forward and reverse engineering. So let's look at the sequence diagram. In the sequence diagram, we know that a customer can send an order request to the order, and the order which on being confirmed can either be a special type or a normal order. And these, when on being dispatched, it will be a self-declaration which will return the order to the order level, and also the order will be returned to the customer. This is the sequence diagram. Now let's look at the collaboration diagram. The collaboration diagram, as we know, lays emphasis on the structure. So here the initialization of the object is done, and then an actual object of the customer is created. This sends an order request to the order, and this on being confirmed will be dispatched as either a special order or a normal order. And after the dispatch is done, it will go into the end of process state or the termination state. The state chart diagram tells us about the state in which the system is in. That is, it describes the state of the machine or the model. It keeps a track of the system's reaction to internal or external events. The purpose of state chart diagrams are as follows. They are used to model the object state of a system. They are used to model the reactiveness of a system. And they are also used to identify the events which are responsible for bringing a state changes. They are also used in forward and reverse engineering. Now let's look at the UML diagram. At the starting, we'll be in an initial state, and then the customer is idle. He'll be sending an order request to the order object. From there, he'll select whether it's a special order or a normal order. And once the order is confirmed, it will go into the confirm order state and then it will be dispatched. On dispatch state, it will indicate the completion of the process and will go into a termination state. Similarly, when the order request gets cancelled for some reason, it will go into an abnormal exit and then goes into the termination state. The activity diagram is the last section of the behavior diagrams. The activity diagram is basically a flow chart to represent the flow from one activity to another activity in the system. The purpose of activity diagrams is to model a system using the activity flow. They are also used to model the business requirements for a particular system. Using the activity diagrams, we can acquire high-level understanding of the system functionalities. Now let's look at the activity flow diagram. So initially, we're in this state, and these are the two activities. So the customer orders, and then the order gets confirmed, and then it will check whether the order is normal. And if it is a normal order, it will directly be prepared. If it's not a normal order, it will be checked whether if it's a special order. If it's a special order, it will be prepared again. And then it will be dispatched. On completion of the dispatch state, it will go into the termination state. In case if the order is not special and not normal, then it will go into an observed state and it will lead to a termination state. So that's all about the UML diagram, guys. In this lecture video, we completed the introduction to UML and the description of various UML diagrams. Hope you liked the lecture. Thank you, guys.